Okay, geometry, we're looking at 11-6. We're doing some surface area and lateral area, of course, on some other shapes today. It looks like we're going to be doing some pyramids and some cones, and then we may actually combine some of the ones yesterday, maybe make a composite figure, but let's just focus on pyramids and cones first. So, for our pyramids, something a little different today. So we're going to talk about the lateral area first. Okay, and in a pyramid, the lateral area is going to be 1/2 of the perimeter of the base times the slant height. Okay, 1/2 of the perimeter of the base times the slant height. Okay, so lowercase l is slant height. And I'll show you what that is here in just a minute. Oh, what's going on? It's okay. Let's get a T right there. And then get rid of that magic. Okay, so for a pyramid, the lateral area is 1/2 of the perimeter times the slant height. And so at this point, then we're going to have the surface area, and the surface area is going to be the area of the base. Okay, so surface area is going to be the area of the base, okay, plus the lateral area. Area of the base plus the lateral area. You could also look at that as area of the base plus 1/2 of the perimeter times the slant height. Oh, hello. There we go. So again, L, the lateral area, and 1/2 perimeter times the slant height is the exact same thing. Okay, so let's take it and add a shape. I'm going to pull up a pyramid and we'll keep going. Okay, so here we have a pentagonal, however you want to say it, potato, potato, we can still be friends. And so the area of the base, or the base, is going to be a pentagon. And then because it's a pentagon, that means it has 5 faces around the side that are connected to that pentagon that meet up at the original vertex at the top. So the slant height is the distance. Let's see what's going to be the best color for this one. Probably yellow. The slant height is the length from the base to the vertex. Okay, so there's our L, which is our slant height. Now, don't confuse that with the actual height. Let's see what would be another good color. Let's go with red on this one. The actual height would have to be drawn perpendicularly, and it would end up right in the middle of the shape. So we may have to use that. What you will see is we can probably create a right triangle here. Okay, it's a horrible drawing, but and we may need to use that actual height to find the slant height by making a right triangle and doing a squared plus b squared equals c squared. So back to the red, this would be the actual perpendicular height, okay, of that pyramid. Okay, so there will be some examples in class tomorrow, or excuse me, on next Tuesday. No, I shouldn't say that because days may not match up. In the next time we're in class, there will be some examples on that. So let's look at cones. Okay, cones are unique. They're going to have a circle base on them, so we know we're going to have probably some pi, maybe some radius, something to that effect. Okay, so the lateral area of a cone is going to be pi times the radius times the slant height. Okay, so lateral area is pi r L. Again, L being the slant height. And then if we're going to do surface area, it's going to be the area of the base. Okay, so surface area is going to be area of the base plus the lateral. Now, area of the base of a cone is going to be a circle, so that's going to be pi r squared plus pi times radius times length, not times length, times slant height, excuse me. Okay. So again, just another way of writing surface area. And so let me pull up a cone and I'll label that slant height and we'll just get a look at what it looks like. Okay, so there's a cone and then make it the same. Let's see, I did the slant height in yellow. Okay, so just two new formulas, one for lateral area and surface area of pyramids, and one for lateral area and surface area of cones. Just a little over 7 minutes.